Today we're going to talk a little bit more about estimating decimal numbers, and we're going to use that to help us in some problem solving today. So if you wanted to quickly count how much money you had, would you count the bills or would you count your coins? Well, you would just get a quick estimate of how much money you have by counting your bills, right? Because they're worth more than the coins. Okay. In this decimal, 0.265, 265 thousandths, which digit has the most effect on the value of this number? Again, just like in the previous example, it's the digit that has the most value, right? Which would be the tenths. So the 2 has the most effect on the value. 2/10 is a whole lot more than 6/100 or 5/1000, right? So the digit with the greater place value is often the one that you would round to, or that would give you a quick estimate, an easy estimate, if you were trying to estimate a sum or a difference in decimals. So this is a picture of something called quarter round. Quarter round is just a molding that is put below the baseboards around the outside of a room when a builder builds. And quarter round can be bought in 3-meter lengths, and every length of 3 meters costs $8. Okay? So suppose you had a room that was 3.62 meters long and 2.43 meters wide. And we would need just to do a quick estimate in our head to figure out how many lengths of this quarter round we would need if we know that 3 meters of quarter round is $8. Okay, well, to do a quick estimate of this room, of the perimeter of this room, the distance around the outside where I'd be putting the baseboards, probably would make sense to round to the ones place to estimate the length of the perimeter. Okay, so like we did yesterday, when you're rounding to the nearest whole number, that's your ones place, and you look at the digit to the right of it, and if that digit is 5 or greater, it means this 3 will bump up to become a 4. So this room has a length of about 4, so 4 plus 4, and then a width of, well, rounding to the nearest whole number, the 2 has a 4 after it. If the digit that comes after it is 4 or lower, this 2 will remain a 2. So the width of this room is about 2 and about 2 meters. So plus 2 more meters, plus 2 more meters. That gives us an estimate of the perimeter of the room being 12 meters. Well, that should work out quite well then, because our boards come in 3-meter lengths, and so it would take 4 of those to make 12 meters altogether. Okay, so I can do a quick calculation in my head. If each 3-meter length costs $8 and I need 4 of them, that would cost me about $32 to put this quarter round around the perimeter of my room. But will 12 meters be enough? Let's calculate the exact amount needed. Well, if instead of estimating, instead of rounding those numbers, if I actually calculated the exact perimeter of this room, I get that the perimeter is actually 12.1 meters. So if I've only bought 12 meters of quarter round, that won't be quite enough. I would actually need to buy a 5th 3-meter section of quarter round, wouldn't I? To make sure that I have enough for 12 and 1/10 of a meter more. 1/10 of a meter is 10 centimeters, right? 10 centimeters more than 12 meters. Okay, so when you're estimating, sometimes it makes sense to round in different ways. It kind of depends on the situation. In a case like this, there is a chance that you wouldn't be putting this quarter round around the whole room. For instance, there might be a doorway where your quarter round would stop at a certain point and then start again. And so 12 meters a quarter round might just be enough. Your estimate, rounding to the nearest whole number and getting an estimate of 12 meters might just be enough. But in other situations, you're going to want a closer estimate. And so you might round to the nearest 10th of a meter. So today we're going to look at a few different ways that we can round, and it really is specific to the certain situation that you're in, which way would make the most sense. Okay, so we're going to have a look at a couple questions from the assignment that you'll be doing, where it introduces 3 different ways to estimate sums and differences. Okay, the first one is to estimate the sum or difference just using the whole number parts of the decimals. So in other words, we're not looking at what comes after the whole numbers at all. We're just taking the whole numbers as they are. So for example, 32.456, we're just taking the 32 part. And 6.71, doesn't matter that it has a 7 after the decimal, we're taking just the whole number part, the 6. And this 0.253, we're just taking the whole number part, the 0, and we get an estimate of 39. And there are occasions where it makes sense to do that. Okay, so let's try that with this first example. 2.785, if we take just the whole number part, that's the part before the decimal. So that's 2. The part before the decimal, the whole number part is 3. And in this case, the whole number part is 20. So I've got 5 plus 20, so my estimate would be about 25. Okay, we'll try one more of these. The whole number part is 12. Don't worry about what comes after it. We're not doing rounding to the nearest whole number or rounding to the nearest tenth. We're just taking the whole number parts. And in this case, we're subtracting 4 is the whole number part there. So our estimate is about 8. Okay? This doesn't get us a very close estimate because we're ignoring the fact that there is a digit after that whole number part that would either keep that whole number part as is or it would bump it up. But it gives us an estimate if we were just looking for a quick estimate in our head. Okay? If you look at number 2, number 2 is very similar, except this time we want a little bit more accurate estimate. So this is where we would round to the nearest tenth. Okay, so for instance, 2.877, the digit in the tenths place is the 8. It has a 7 after it. Remember, if the digit after it is 5 or greater, this 8 will bump up and become a 9, right? So this 2.877 becomes 2.9 rounded to the nearest tenth. Remember, with decimals, we don't put the zeros in afterwards like we do when we're rounding with whole numbers. Okay? We want it to be to the nearest tenth, so it needs to be to the tenth position. That's called rounding off. Okay, plus 3.6, well, the 6 is in the tenths place. It has a 2 after it, so that means the 6 will rest. If it's 4 or less after the 6, you let it rest. So 3.6. So when we add 2.9 plus 3.6, we get that our sum is approximately 6.5, 6.5. Let's try a couple of these. Okay, so rounding to the nearest tenth. Here's my digit in the tenths place. It has a 6 after it. So what will happen with that 7? Hopefully you identified that it would round up to an 8. 8 tenths minus, here's the digit in the tenths place. It has a 5 after it. So that would round up as well to a 4 in the tenths place. Okay, 0.8 minus 0.4. 0.4. Okay, we'll do the next one too. 25.08. 0 is in the tenths place, but it has an 8 after it. That means that 0 is going to bump up and become a 1. So that's about 25.1 plus, here's the digit in the tenths place. It has a 0 after it, so it's going to remain a 0. And here's the digit in the tenths place. It has a 3 after it, so it will remain a 5. It will rest. Okay, 25.1 plus 4.5 is 29.6. Okay, so you can see that this is giving me a little bit closer estimate, a little more exact, closer to what the actual sum or difference would be, okay, when you round to the nearest tenth. Okay. There is one other way that you can estimate, and that is by using the digits of the 2 highest place values. Okay, so for instance, we know that the digits to the furthest left are higher place values than the digits on the right. So 3.2 is what we would use, the first two highest place values. Okay, and in 0.76, it would be the 0.7. Okay, and then we subtract those and we end up with an estimate of 2.5. Same with this one, we have 0.54. Okay, so we'd use the 5.4 part, and we'd use the 0.06, the 0.6 part. And if it helps when you're trying to add those, to put in zeros in places that you need to, you can do that, it says. Okay, and you can see that we're adding 0.54 and 0.06, and we get 0.60. Okay, so let's try this. The two highest place values in this number would be your tenths and your ones, right? So that would be 9.1 plus, in this case, again, it's tenths and ones, 1.8. And when we do that and we're adding, we have, if we're adding our tenths, we've got 8 tenths plus 1 tenth, that's 9 tenths. And in the ones place, I've got 9 ones plus 1 1, that's 10. So 10.9. Okay, and let's try the second one. Highest place values would be your tenths and ones again, tenths and ones again, tenths and ones again. So it'll be approximately 3.2 plus 2.5 plus 4.1. Okay, and if I added those, adding the tenths first, I've got 1 plus 5 plus 2, that's 8. And 3 plus 2 plus 4 is 9, about 9.8. Okay. Okay. So if you had a scenario like this, Andy had $755.50 and spent $326.87, which of the methods on the previous page would you use to estimate how much money he has left? Which of those three methods do you think would be the most logical in this situation? Using the whole number parts, rounding to the nearest tenth, or using the two highest place values? I think if it were me, I would want to know as close as I can how much money I actually would have left. And so for me, I would round to a certain place value. I think I would round to the nearest dollar, which means to the nearest whole number. So that means my ones place. Okay, so $755.50. That would round, oops, 750. And what would happen to that 5? If it has a 5 after it, that 5 will round up to a 6, right? Okay, so this is approximately how much money Andy had to start with, but he spent 320, well, the 6 has an 8 after it, so the 6 is going to round up to a 7. He spent approximately $327. So in my head, I can just really quickly figure out approximately how much money he has left. 6 minus 7, well, I can't do that, so I go next door. I borrow 1 from the tens. That puts 10 more here, but I already have 6, so I have 16 now. 16 minus 7 is 9. 4 minus 2 is 2. 7 minus 3 is 4. He has approximately $429 left.